Now in this example, expand 2 plus 3x raised to negative 6 up to 3 times, isn't it? Hence, take its validity. So the first thing you know is this. Up to 3 times, when you have 1 plus x raised to power n, you know the first term is always 1, the second term is n x, isn't it? Then plus, you see I'm leaving some space because there's something I want to add there, isn't it? Then plus, or because I will put a next line, plus the third term. When you have 1 here, this was 0 factorial, isn't it? This was 0, then this was 1, meaning when you have 2 factorial, there are 2 terms in the numerator, isn't it? Yes. So 2 terms in the numerator is n into n minus 1, isn't it? Then it means our x is now raised to power 2. Here 1 factorial, our x is raised to power 1, isn't it? Then you move plus, no, up to 3 terms. They wanted it up to 3 terms only, isn't it? See, these are the 3 terms. So the first term here, 1 over 0 factorial is just 1, isn't it? Nx over 1 factorial is just nx. So from here, our problem is 2 plus 3x, meaning here we have 2, not 1, isn't it? So it means where there is 1 we are putting, we now have a plus x raised to power n. Are we together? So it means we add a term of a in everything, isn't it? So here we add 1. If we add a term of a, it is going to be a raised to power n, because x was raised to power 0, isn't it? Then the next one here we add nx. Then it means our a is now going to be raised to n minus 1, because x is raised to power 1 there. Are you seeing? Are you seeing we are now adding a? Yes. In that problem, isn't it? Yes. Then the next one we had n into n minus 1 over 2 factorial then x squared, meaning our a is now going to be n minus 2, the power of x, isn't it? Yes. So here, when we have 1, it is just as simple as that. But now when we have a, you add the term for a. Is that okay? Yes. So here we have x raised to power 0, meaning a is raised to power n. Okay? Good. So you go to your problem 2 plus 3x raised to negative 6. Meaning a is what? What is the value of a? Where there is a we have 2, isn't it? Yes. Then what is the value of x? So you see this is also x, so you can let this be x1, isn't it? You let it be x1. So what is x1? X1 is the same as positive 3x. That sign in front is very important, okay? Yes. Positive 3x is just 3x, okay? Yes. Then what is your n? Your n is negative 6. So start substituting. The first time here we only have a to power n, because x is raised to power 0, isn't it? Anything raised to power 0 is 1. Are we together? So a raised to power n, what is your a? Is 2 raised to power n. N is negative 6, isn't it? Yes. You move to the next one, plus n. N is negative 6. x1 is 3x, isn't it? Then it is raised to power 1. That's just 3x, isn't it? Yes. Then you move to a is 2. It is raised to power n minus 1. Notice why n? Negative 6. Negative 6 minus 1 is negative. Negative 6 minus 1 is negative 7, isn't it? Good. Then move to the next one. Plus n is negative 6. Then negative 6 minus 1 is negative 7, isn't it? Over 2 factorial. Then x1 is squared. x1 is 3x, isn't it? So we have x1 is 3x, the whole of it is squared. Then we have a, which is 2, n minus 2. N is negative 6. Negative 6 minus 2 is negative 8. Are we together? Is that okay? So can you now go to the calculator and start? What is 2 raised to negative 6? Two raised to negative 6. 0.015 156. Like that?
Yes.
Okay. Then it is, go here. Now start here. Start with the numbers part. Negative 6 times 3. Negative 18. Negative 18 times 2 raised to negative 7. Negative 18 times 2 raised to negative 7. You have negative 0.1. Negative 0 point? Negative 0 point? 1 person to say it.
1406.
1406, isn't it? Then you can see our x is raised to power 1, meaning it's just x, isn't it? So we are done with this term, we are done with this term. We are going to the last term. Start, move stepwise. Negative 6 times negative 7. 43, 42. Positive 42 divided by 2 factorial. Say the answers, we move stepwise. 21. 21 times 3 raised to power 2. Are you seeing 3 is raised to power 2? Are we together? So 21 times 3 raised to power 2? 189 times 2 raised to power negative 8.
0.7.
0 plus 0.82, isn't it? Then our x is raised to what power here? See, x is also raised to power 2. See, you expanded the whole problem. After the expansion, see, you are also told to state its validity. So we say the binomial series, when you want to state its validity, you equate it to 0 first, isn't it? So for the validity, when you have 2 plus 3x raised to negative 6, you equate it to 0. Meaning, if you raise both sides to the reciprocal, the power will disappear, isn't it? Are we together? Meaning, if you raise both sides to power negative 1 over 6, power negative 1 over 6, that power goes away. Meaning, you just remain with 2 plus 3x is equals to 0. 0 raised to by anything is 0. So it means that power is not important when we are looking for validity, isn't it? It will disappear. So make x the subject of the formula. Go take it to the other side, you remain with 3x is equals to negative 2, isn't it? So that implies x is what? You divide both sides by 3. X is negative 2 over. So if x is negative 2 over 3 and not 2 over 3 is what we need, that implies we have absolute value of x is less than 2 over 3. So if absolute value of x is less than 2 over 3, it means x is within the interval negative 2 over 3 and positive 2 over 3. That's what gives you the range. Negative 2 over 3 to positive 2 over 3, meaning it should be plus or minus. So sometimes you get it to be negative, sometimes you get it to be positive, then you take both ranges for absolute value. Are we together? Is that okay? Yes. So you've actually stated the validity of that series, meaning it is valid when x is between, when the values of x are between negative 2 over 3 to 2 over 3. That is when that given series is valid.